In this chapter, we will be studying radical and absolute value functions. In this lesson, we will be solving radical equations.
Right. Hi, everybody. Now we're going to move on here, and we are going to spend some time solving radical equations. Okay? Now, our equations typically get named based on where the variable is. So if you've got, for example, like a trig equation, that usually means that you've got an x or a variable inside a trig function. If it's a rational equation, that usually means that the variable is in the denominator. And so here, when we've got a radical equation, what we mean by that is that the variable is in the radicand. Okay? And so we're going to have an equation. It's got an equal sign. It's got a left and a right side to it, obviously. I mean, that's how you recognize these things as opposed to an expression. Okay? And what we're going to do here typically is to solve these things is you deal with the thing that we named the equation after. So for example, in a trig equation, you've got like a sine or cos or a tan in there. Typically the procedure is to get rid of the trig. If it's a rational equation, you want to get rid of the rational, get rid of the denominator. In a radical equation, we're going to get rid of the radical. Now, in this particular case here, you're going to see that what that will sometimes do is it creates a situation for us where we could very easily have two solutions, one solution, or it could even be possible we have no solutions. And that's because in order to get rid of a square root, and that's as far as we're going to go, everybody, just having an equation with a square root in it, you are going to have to square the equation to get rid of the radical. Okay? But when you square things, you create a result that you could get using two different results here. Just for example here, if I know that 9 is equal to x squared, okay, I squared something to get 9. Well, that something, whatever it is that I squared, could have been positive or the negative 3. There are two possibilities here. So when I take an equation like this and square it to get rid of the radical, okay, the equation that I get as a result, that could have typically two possible solutions to it. And so sometimes what you got to do is you got to check the results. Now, it's one thing to check the results, to just take your answers and plug them back into the equation, see if they work. Another way of doing this is to pay very close attention to the restrictions that you get on the variable because of the radical. Now, what I mean by that is when you take the square root of something, I just want you to think about it. Is there a number out there that you couldn't take the square root of? Now, the answer that I have to give as a math teacher is no, you can take the square root of everything. However, for most of my students here, actually the answer to that is, well, yeah, you can't take the square root of a negative. We're not going to, at this point in time, we're not going to do the mathematics that allows you to do that. That is a dead end for us right now. We're focusing our attention on real values, which means you cannot take the square root of a negative. So that means the radicand, and by that I mean whatever shows up underneath that radical symbol, has to be greater than or equal to 0. Okay? Must be greater than or equal to 0. So for example, in this case right here, if I was to ask you what are the restrictions on this, on the variable in this equation right here, well, I would simply look at the radicand right now and say, well, okay, then my radicand, that 4x, has to be greater than or equal to 0. Now, if I want to know what the restriction is specifically on x, I need to get rid of the 4. So I would divide both sides by 4, and that's simply going to get me x is greater than or equal to 0. Okay? Over here in this equation, the radicand is x plus 3. And in this case, that means the x plus 3 must be greater than or equal to 0. If I want to know what the restriction is on just the x, I would move the 3 over. So I would subtract the 3 from both sides, and that tells me that x has to be greater than or equal to negative 3, and that's my restriction. So a couple ways I can check my answers is to simply go to my restriction and say, okay, do the answers that I get, do they all or do any of them satisfy the restriction that I got on that variable? If yes, then those are solutions. If not, then you ignore them. Okay, so let's take a quick look then. What are the steps to solving a radical equation? Well, here they are. Okay, first thing we're going to do is we're going to rewrite the equation so that the radical is isolated. Now, that is not absolutely 100% necessary. However, it does make your life a lot easier. Now, especially if you've got one radical in the equation, Okay, you really need to isolate it. That's the only way you're going to get rid of the radical is if you isolate it. Okay, particularly if there's other terms. If you've got a radical on one side that's maybe got a coefficient, the coefficient's not the problem. It's if you've got another term there. If you've got two terms, like for example, this equation up here. Okay, there are two terms here, the root 4x minus 7. Well, I really need to get that root 4x by itself first. If you've got two radicals in the equation, leaving them both on one side is okay, but you probably want to set it up so that you've got them on both sides. Okay, and then one of the radicals is isolated, if you've got two in there. Next thing you're going to do is you're going to square both sides, because that's going to get rid of the radical, or at least if you've got two radicals, it's going to get rid of one of them. You're going to combine like terms and solve the equation, because at that point there, once you've squared it, you really should have a polynomial that you're looking at. Now, if you don't, if there's still a radical in there, then you're going to have to isolate that radical and square both sides of the equation, but that should get rid of it. And at this point in this course, that is as bad as they're going to get. So you're going to solve that polynomial equation that you get, and then you're going to have to check to see if those roots work. Please check. This is not one of those things that I'm asking you to do just because I want you to do a little bit more math and it's a good idea to check to see if you got the answer right. No, this is a necessary step because you could very easily have gotten answers that actually don't work in the equation. Now, if that doesn't make any sense to you right now, it will make sense to you after we go through and take a look at a couple of examples. We call those extraneous roots. Okay, answers that you get, okay, because of some of the algebraic steps that we take to solve equations, every once in a while we create a little bit of ambiguity in the equation where I don't know, for example, whether the answer should be positive or negative. It seems like both of them could work. If there's a square in the equation, having a positive or a negative being squared is going to get you the same result. So there's a little bit of ambiguity. So you really do have to check your answers. Now, you're either going to check them by plugging them into the original equation and seeing if they work, or you're going to compare them to the restrictions that you would have found. Anyway, let's take a look at some examples to see what this looks like. All right, so the first set of questions we're going to do here, we're asked to simply state the restrictions on the radicand. Okay, so here, now, there are some more restrictions here because you've got it set equal to y because you've introduced another variable here. But we're not going to worry about that right now. We're simply going to look at this part right here. Because in the equations that we're going to be looking at, for the most part, they're going to be a little bit simpler overall. When you get to the next level, you're going to see that there's another restriction here that you should take a look at. But here, square root of x. So that means whatever's under the radicand has to be greater than or equal to 0. And because it was just x all by itself, as soon as I write that out here, that is the restriction. So when I solve my equation, okay, now I know it's equal to y, but whatever y is equal to, whatever expression I have in there, as long as my x value is positive or 0, I'm fine. Here, my radicand is x minus 3. Well, in order to get real answers, that means x minus 3 has to be greater than or equal to 0. And now I'm going to isolate the x there, so I'm going to add that 3 to both sides. And so my overall restriction here, that means that x has to be greater than or equal to 3. Now, just so that you get a sense of what's going on here, pick a number bigger than 3. Let's say 5. 5 minus 3 is 2. Can I take the square root of 2? Yes. Pick another number here that's less than 3. Let's say 1. Okay, now that does not satisfy this restriction, but you're going to see what I mean here in just a second. If you plug 1 into this, 1 minus 3 is negative 2. Can you take the square root of a negative? Well, no. At least in this course, no. The answer to that is no, you can't. Over here, we're going to take a look at the restrictions on the variable, but I want you to remember here that for the time being, at least for right now, we are focused on the radical. I don't care about that extra term. Okay, that minus 4 there, not an issue. Not an issue. I am only concerned with the radicand, and in this case, it's just x. So my restriction is that x has to be greater than or equal to 0. Okay? Now, one more. The square root of 10 minus 2x. Now notice that I've got, again, a binomial underneath the radical here. So my radicand is 10 minus 2x. I know that that must be greater than or equal to 0. Now, there are a couple of ways that I can do this, but I'm gonna choose to do this in a very specific way so that I can talk about a little bit of algebra here that you may or may not have remembered here. I'm going to try to isolate that negative 2x first by bringing the 10 over. Now, that means when I bring that 10 over, I'm going to subtract. It's going to be negative 10 on the right-hand side. Notice that this negative stays with the 2x. Okay, that's because it's in front of the 2x. When I move the 10 over, I don't move any sign behind it. Okay, what's behind it is irrelevant. What's in front of it is relevant, but what's behind it isn't. Now, for me to get the x by itself, I need to get rid of that negative 2 there, which means I need to divide both sides of this inequation here by negative 2. So those will cancel. I'm going to get a 5 on the right-hand side, but remember, it's probably been a while, but just remember how this works. When you divide or multiply both sides of an inequation by a negative, that changes the direction of that inequality. So in this case here, x, in order to satisfy this equation, in order to be able to take the square root, x has to be less than 5 or equal to 5. Now to illustrate that, let's pick a number. Let's say 4. Well, 2 times 4 is 8. 10 minus 8 is 2. Can I take the square root of 2? Yes. Now just to check this, let's pick, for example, 6. Now, based on what I'm seeing right here, 6 shouldn't work. 2 times 6 is 12. 10 minus 12 is negative 2, and there we go. No, I can't take the square root of the negative 2. So that works. That is my restriction. All right. Now for this question, we're going to solve each radical equation. Okay. So this first one is set up beautifully for us because the radical is isolated on the left-hand side. So what I'm going to do is I'm going to square the equation. Now when I do this, what I really mean here is I'm going to square the left side, square the right side. Because bear in mind what this is saying. Before I draw that stuff in here, this is saying that the square root of 2x minus 1 is equal to 3. Like, before we get into solving for x, let's just be clear on what it's saying. That little statement right there is stating equality between these two. They are already equal to each other. So if I square the left-hand side and square the right-hand side, their squares should be equal to each other. If they're the same, then their squares should be the same. So that means if I square the right-hand side, that's easy. That's going to be 9. If you square the left-hand side, when you square a square root, all that does is get rid of the radical. Okay? If you square a square root, now if you're not sure what I mean by that, just think about that. If I take the square root of 16, okay, you know what that is. The square root of 16 is 4. If you square that, you'll get 16. The square root of 16 is 4. And then you square that, you go right back to 16. So the square root and the square, they're basically canceling each other out. They're inverse operations. So here, what that's going to do is that's going to just get rid of the radical. I'm going to get 2x minus 1 now is equal to 9. I'm going to add that 1 to both sides and then divide by 2. And x is equal to 5. Now, does that work? Well, there are two ways that I can check this. And I'm going to, for the first little bit here, I'm going to be a little bit slow with this. Okay? If you take 5 and plug that in, 2 times 5 is 10, minus 1 is 9, and the square root of 9, that is 3. That works. The other way of checking this is to look at the restriction. 2x minus 1 has to be greater than or equal to 0. Okay? Now if I work to solve for the x here, I'm going to add the 1 to both sides, and then divide. And I get that my x value must be greater than a half. Well, 5. Is 5 greater than a half? Yes, it is. So again, I know that answer of 5 works. Right. Now we're going to solve this equation right here. Notice on the left-hand side here, I've got a radical and I've got a variable here. I've got two terms. I want to isolate the radical here. If you don't, if you just try squaring this equation right now, you'll have to remember from a previous lesson here that when you square a binomial, it won't get rid of the radical. Okay, squaring a binomial won't get rid of the radical. So I do need to make sure that this isn't a binomial here. So I'm going to bring the n over. That'll give me negative n plus 13. Now, the right-hand side here isn't particularly pretty. That negative in front doesn't it's not very pretty here. So I'm going to factor that out. Now I suspect there's going to be a whole bunch of you there that'll be like, why did he do that? Okay. But in a couple of steps here, I also suspect that there'll be a lot of people that'll go, yeah, you know what? If I didn't do that, if I don't factor out that negative and make that binomial look pretty, I would probably square that wrong. Okay. Now, if you're okay with that, by all means, you can get right here. You can just square that, and you're good to go. I recommend factoring that out here, because now what I'm going to do is I'm going to square both sides of this equation. On the left-hand side, when I square that, I'm going to get n plus 7. Now remember, on the right-hand side, when we square, that negative is going to disappear. Okay, so it's going to become positive, and this is just going to end up being n minus 13 squared. Now, if you didn't factor out the negative, then you'd have to be concerned about what that negative in front of the n is doing. And a lot of people just end up doing that wrong. They're just not careful enough in their algebra to deal with that and then think about what's going on with the 13. Now, the answer here should be n squared minus 26n plus 169. Now, if the group of people here watching this are basically a representation of the general population, then there's going to be a whole bunch of you out there wondering, where on earth did that negative 26n come from? Okay, that's because people tend to be very inconsistent with the rules of polynomial multiplication here. And it's a very predictable thing, but at the same time, it's a really frustrating thing for both sides. It's frustrating as a teacher to watch students repeatedly do this wrong, but it's also frustrating for students who repeatedly do it wrong, because if you do it wrong, you'll recognize this immediately as a pitfall that you fall into. So n minus 13 squared, bear in mind that that means n minus 13 times n minus 13. Okay, and when you multiply binomials together, you have to distribute. So it's going to be n times n squared, n times negative 13 times n, and then negative 13 times negative 13. And when you add together those two middle terms, you're going to get the negative 26n plus 169. Now, you know that you're supposed to do that. But a lot of people will immediately just square the first term, square the last term, think they're done, and away they go. Please remember, whether you call this FOIL or just distribution, please remember that when you're squaring a binomial, you're going to get that middle term there. So anyway, back to our problem here. So now we've gotten rid of the radical. Great, we needed to do that. It's a quadratic now. I see that with the n squared. So now what I got to do is I got to bring all the terms over to the to one side. I'm going to bring them all to the right-hand side. So this will be minus 26n, and then I'm going to subtract the 7 from there to be 162. Now, to solve this, I'm either going to factor this, or I'm going to use the quadratic formula. Let's just think about this. 162. It turns out, yeah. So my factors here are going to be negative 18 and then negative 9. When you multiply those together, you're going to get your 162, and when you add them together, you're going to get your 27. So my answer here is either going to be 18, so positive 18, or positive 9. Now, I don't know. Do both of those work? I'm not entirely sure. Let's just take a quick look up here. If you take 18 and plug this in, what's 18 plus 7? Think about that. It's 25. Square root of 25, it's going to be 5, plus 18 is 23. Because remember, n is supposed to be 18 in this case. If I plug that in, it does not equal the right-hand side. 18 doesn't work. Now let's try the 9. If you plug the 9 in, what's 9 plus 7? Okay, 9 plus 7 is 16. Square root of 16 is 4. 4 plus 9? 4 plus 9 is equal to 13. Okay, so there we go. So 9 works. Our solution there has got to be equal to 9. Okay, so that's one way that could definitely work there. So you can check that out. Perfect. Now you might be wondering how we might get these restrictions. The answer here, the correct answer, if I look at the restrictions based on restrictions on the variable here. Let's take a quick look at that. So notice that under the radical here is this n plus 7. So I know, let's go over here. Maybe we'll draw a line here. I know that the n plus 7 has to be greater than or equal to 0. Whatever you're taking the square root of must be positive. And if I bring that 7 over, I get that n in this case must be greater than or equal to negative 7. Well, both my 18 and my 9 are bigger than negative 7, so why didn't they both work? Why does it only work with 9? Well, it's because of one other little detail here. And this isn't something that you really need to spend a lot of time focusing on right now. You really don't. Your best method for checking to see whether you've got extraneous roots is just to go back and plug them in. But here's another way to think about it. When you take the square root of a number, and to get this restriction, you really do have to be looking at it in the form right here where the radical is being isolated. When you take the square root of a number, not only do you have to take the square root of a number, but the square root is, by definition, when we write it in this form, is by definition going to be a positive number. Okay? So, and I know some people are going to really struggle with this idea, but it does make sense. It is very consistent with the math that we do here. When I ask you, for example, what is the square root of 9? The answer is 3. The answer is not plus or minus 3. The answer is 3. That's because this symbol here is related to a geometric idea. You're being asked here to find the length of a side if the area of a square is 9. Well, the length of a side can only be positive, so the answer is positive 3. Now, if I told you that x squared is equal to 9, squaring removes a possible negative there. Now, they are related ideas. These are very related ideas, but this is asking more of an algebraic thing. What number squared gets you 9? And well, the answer is it could be positive or negative 3. But if I'm saying that the area of a square is 9, what's its side length? The answer is only positive 3. We call this the principal square root. Now, what that means is, and how that relates to this is, when you take the square root of an expression, the result must be a positive number. So whatever that radical is equal to must also be positive. So here's one restriction. And then I know that negative n plus 13 must also be positive or 0. And so if I bring the 13 over, I get negative n has got to be greater than or equal to negative 13. And when you divide by the negative, we get that n must be less than or equal to 13. So the number I'm looking for, the actual answer to this equation here, has got to be greater than negative 7, but less than 13. And if you look at my two possible answers here, 18 and 9, 9 is the only one that actually satisfies both of those conditions. Now, at this point in the game, we really don't expect you to be thinking this thing through totally like that. I'm showing that to you really because it's an idea that you can get right now. It's not totally out there. You can use it to help you through these problems if you wish, or just content yourself with just plugging stuff in. Now, I'll probably refer back to that rule one or two other times here, maybe with the next question, that's about it. Then we'll just be checking them, okay? Anyway, let's go on to the next question here. All right, here we go. The next one here. Y minus 2 is equal to the square root of y minus 1 plus 1. Okay, so the very first thing we got to do is isolate that radical. So I'm going to bring that 1 over, and we'll get that 1 minus 3 is equal to the square root of y minus 1. Now, I tell you what. Based on what we just did in that previous question, let's come up with our restrictions right now. So first of all, I know that y minus 1 must be greater than or equal to 0. Whatever's inside the radical must be positive. And so I know when I bring that 1 over that my y value has to be greater than or equal to 1. But additionally, I know that whatever my radical is equal to also must be positive, because the square root of a value is always going to be the positive value, never the negative. So I know as a result that whatever's on that other side of that equation, that also has to be positive. And if I bring that 3 over, I get that y must be greater than or equal to 3. So now when you look at these two restrictions together, y has to be greater than or equal to 1, y has to be greater than or equal to 3. Well, if the y value has to satisfy both of these, which one is it going to satisfy? Well, it's going to be this one. So whatever the value is, whatever the answer to this equation is, it's got to be greater than or equal to 3. Now let's go back to the equation and let's solve it. So we're going to square both sides of the equation to get rid of the radical. So on the right-hand side, that's going to end up being simply y minus 1. On the left-hand side, I'm going to square that binomial, that y minus 3 squared, which means y minus 3 multiplied by y minus 3 will equal y minus 1. Now I'm throwing in this additional step here more than anything just to remind people of what you got to do. When I expand this out, I will get y squared minus 6y plus 9 is equal to y minus 1. Now, if you're wondering again where that negative 6y is, please just take a few moments here and FOIL this one out or expand this one out. You will see where that negative 6y comes from. Now I'm going to bring the y and the minus 1 over. So y squared minus 7y plus 10 is equal to 0. And when I factor that, I will get y minus 2, y minus 5 is equal to 0. And look at that. That gives me two answers here. Y has either got to be equal to positive 2 or 5. But we just saw that y has to be greater than or equal to 3. So it can't be 2. The answer's got to be 5. Now, let's just double check our answers here. Let's take 2 and plug that in. What's 2 minus 2? 0. Okay. So what's 1 minus 1? Oh, sorry, I'm sorry, 2. What's 2 minus 1? 1. What's the square root of 1? 1. Plus 1 is 2. So this is telling me that 0 is equal to 2. If you plug 2 in for an answer, it doesn't work. And again, that's because the square root can only produce the positive value, not the negative. Now if you plug 5 in though, 5 minus 2 is 3. On the right hand side though, 5 minus 1 is 4, square root of that is 2, plus 1, there's my 3. So 5 works, but 2 doesn't. Okay, my next question right here, notice I've got 2 square roots in this. So what I need to do first of all is isolate one of them, and I'm thankful that one of them is already isolated. Now, I could have them both on one side of the equation. That would work too, but this way is probably a little bit easier to work with. Now, in this case, I could content myself with looking at the restrictions underneath the radicals. That's not really going to give me a complete picture. Setting it equal to the other side, greater than or equal to 0, again, it's going to start to get a little bit more complicated with 2 radicals in there. So in this particular case, the most efficient thing you could do is you go back and just plug in your answers that you get and just see what works. Okay, I'm just saying that because comparing this radical and then whatever this is equal to, making that greater than 0, whatever the square root of 3x is equal to, setting that greater than 0, that's just a lot of work. That's really not necessary in this case. So we're going to square both sides. On the right hand side, because it's just the one term, when I square it I'm going to get 5x plus 1. On the left hand side, when I square that, I need to make sure that I write this out as if it's a binomial being squared. Then I need to FOIL this out. Root 3x times root 3x is 3x. When I multiply this out twice, I'm going to get 2 root 3x terms, and then 1 times 1 is going to give me 1. Okay, squaring that binomial did not get rid of the radical. I still need to get rid of that radical, so I got to isolate this radical here. So I'm going to bring the 3x and the 1 over. So 5x minus 3x is 2x. The 1's basically cancel. Now at this point in time, I don't necessarily have to cancel out the 2's, but because it's such an easy thing to do, I'm going to divide both sides by 2. That's wonderful, easy to do. And now to get rid of that radical, I will square both sides. You've got to remember that to square that x squared there. And now when I bring that 3x term over to the right hand side, it's a quadratic, I can factor that out. Okay, and now I'm going to get x is equal to 0 or x is equal to positive 3. Now in this case, because I had the 2 radicals in there, as I suggested before, it's a lot more complicated to figure out what the restrictions are on the variable. It's a lot easier just to say, okay, let's just see if 0 works. Well, 3 times 0 is 0, square root of 0 is 0, so the left-hand side is 1. 5 times 0 is 0, plus 1 is 1, square root of 1 is 1. So, hey, 0 works. Let's check 3. 3 times 3 is 9, square root of 9 is 3, plus 1 is 4, okay. 3 times 5 is 15, plus 1 is 16, square root of 16 is 4. Well, so this is a neat example, because in this case, both of those answers work. I've got 2 different solutions, and both satisfy the equation. That's awesome. All right, Let's do another one. Whoops. Oh, let's wait for a second. There we go. Okay. Now, in this case right here, notice I've got two radicals on the right-hand side. Sorry. Wow, I can't believe I said that. That's embarrassing. Sorry, left-hand side. I do know left and right. Now, I just want to show you this here. I could isolate one of those variables. I could, but it's not absolutely necessary. Okay, I'll show you what happens if you don't. If I square both sides here, first of all, on the right-hand side, I'm going to get 25. On the left-hand side, I simply have to remember that it's going to be that binomial squared. So when I square that, it's root x plus 5 multiplied by root x plus 5. So there's a lot going on there. That equals 25. I just got to remember to distribute. Root x times root x is x. Now, when I multiply this radical by this radical and add them, I'm going to get two of them. And that's going to be 2. And that's what's inside here will be x times x plus 5. Okay? Because root x times root x plus 5 will be x times x plus 5 inside the radicand. X plus 5 times x times x plus 5 in the radicand. There's two of them. And then root x plus 5 multiplied by root x plus 5, the roots will just cancel. Okay. Now, notice that I've only got one radical left, and that's exactly the same as I would have happened if I'd taken one of those initial radicals to the other side. It doesn't matter, as long as I do this correctly. Now, though, I am going to isolate this radical, so it'd be 2 root, and I'll just multiply that through x squared plus 5x. I'm going to bring those two x's over, so negative 2x. Then I'll subtract the 5, so plus 20. Okay, I'm going to factor out the negative 2 there, so 2 root x squared plus 5x is going to equal negative 2 x minus 10. And then I'm going to divide the 2's out. Now, I'm not going to divide out the negative. I'm going to leave that there. I don't want to start moving that around. I can leave it there, but I'll divide out the 2. So it'll be x squared, sorry, the square root of x squared plus 5x is equal to negative x minus 10. And now I'm going to square both sides of the equation, and we've done this before. On the left-hand side, I'll get x squared plus 5x. On the right-hand side, the negative will cancel because I'm squaring it, and then I can just square this binomial. It's a lot easier to square this binomial. Bear in mind that that's going to give us x squared minus 20x plus 100. Okay, and again, if you're wondering where did that negative 20 come from, then just, I beg of you, just take some time, apply the square to the binomial, write it out twice, and then square it. My x squared terms are going to cancel. I might bring that 20 over to get 25x is equal to 100, and then I divide, I'll get x is equal to 4. Love that. That's a great little answer. But now let's just see if that works. What's the square root of 4? 2. 4 plus 5 is 9. What's the square root of 9? 3. 2 plus 3 is 5. So the answer here, 4, works. Excellent. And again, in this particular case, I probably wouldn't start looking for the restrictions under the radicals unless they told me to, simply because I've got a fair bit going on there. I just want to make sure that my answer works. So in this case, the easier way to do that is just to go plug it back up in the original and check it. Okay. Well, this next question here is sort of in a word problem. Basically, it's just the description of an equation in words, and sometimes that can be quite difficult to interpret. I sympathize with people that have trouble with that. So let's just read this thing through here, and let's see if we can grab the pertinent information out here. It says when the square root of when the square root of 2 less than a number. Okay, 2 less than a number. Now, a lot of times people read this as if it's just in that order, and it's supposed to come up in that order. It's like 2 less than a number. But it's the word than that actually makes all the difference here. This is not 2 minus x. Okay? If somebody is 2 years younger than you, okay, that does not mean that you take their age and subtract it from, like you take your age and subtract it from 2. Like I'm 43 right now. If somebody is 2 years younger than me, I don't take 2 and subtract 43 from it and say, oh wow, you're negative 41? Amazing. No. You take that number, x, and then subtract 2 from it. This is 2 less than a number. and we're talking about the square root of that. And then this is subtracted from, okay, so it's taken away from the square root of 5 more than twice a number. Okay, 5 more than twice a number. Well, 5 more means add 5, and twice a number is multiply by 2. Okay, and this is the square root of that right there. So it's the square root of 2x plus 5 minus the square root of x minus 2. Now, I know that for some of you, you're going to get frustrated by that because we seem to be building this equation backwards. But oftentimes, that's just how we talk. Okay, that's just how we say these things. And the result is, okay, and usually the state of being verbs like is, am, are sort of thing, those are your equal signs. So the result here is 3. Now, in the previous question, when I had 2 square roots there, I left them both on the same side. Okay, and just to illustrate that this isn't absolutely necessary, what I'll do is I'll bring that square root of x minus 2 over. So this equation becomes the square root of 2x plus 5 will equal 3 plus the square root of x minus 2. Okay, so now, actually I'll zoom in a little bit on this. Now what I'm going to do here is to solve this equation here, I'm going to get rid of a square root. I'm going to get rid of this one right here. Because it's isolated on the one side of the equation, if I square the equation, it's going to get rid of the radical on this side. So this is going to end up being 2x plus 5. And this over here, because this is a binomial being squared, remember that it's going to be more than just the 2 terms. I'm going to get 3 times 3, it's going to be 9. Then I'm going to get 2 terms that are 3 root x minus 2. So there's going to be a total of 6 root x minus 2. And then the root x minus 2 will be squared, and I'll get x minus 2. Okay, good. So that squaring got rid of one of the radicals. And regardless of how you have the radicals organized, it's going to get rid of one of those radicals. Okay, now I'm going to bring everything over. I'm going to isolate this radical term right here. So I'll bring that x over, and so it'll leave me with x. I've got a 9 minus 2 here, so on the right-hand side, together, those two values amount to a positive 7. I'm going to subtract that when I bring it over, so 5 minus 7 is going to be negative 2. So I've got equals 6 root x minus 2. Now before you get excited and think, ooh, I can cancel whatever. No, you can't, because this is x minus 2, and this is the square root of x minus 2. Okay, now in past questions, and I think almost all of the last ones that we've done here, the coefficient in front of the radical you could divide out, and it went away beautifully. But here it doesn't, because if you divide both sides by 6, you're going to get a fraction on the left-hand side. There's nothing I can do about that. So I'm going to, in this case right here, I'm going to say, well, why bother? I'm just going to leave it right there. I will square both sides of the equation. Let's focus specifically on the right-hand side here. I have got 2 factors to this term. I've got the 6 and the root x minus 2. When you square 6, you get 36. And when you square the root of x minus 2, you will get x minus 2. So the right-hand side becomes 36 times x minus 2. Now, it's a fairly common mistake for people to look at this, and what they'll do is when they square this, they'll get rid of the radical, because they know the radical's got to disappear. And that kind of becomes mentally your focal point, right? You know what you've got to do, and so you deal with that, and then you just forget that the 6 also needs to be squared. It's such an easy mistake to make. That's why I want to make sure that I've pointed that out to you so that you're aware of it. Okay? Please make sure you square the coefficient as well. On the left-hand side, I have a binomial. I'm squaring the binomial. I should end up with 3 terms. I will end up with x times x, so x squared. Then I'm going to end up with 2 terms, both of which are going to look like negative 2x. So there'll be negative 4x altogether, and negative 2 times negative 2 will be positive 4. Okay, now, I can see I've got a quadratic here. I'm going to multiply that 36 through on the right-hand side, so x squared minus 4x plus 4. There's really nothing to do there right now. 36x minus 72. Now I'm going to bring everything over to the left-hand side because I've got a quadratic here. So I got a negative 4 and a positive 36 on the right-hand side. When I bring that over, I'm going to get negative 40x. And I'm going to add that 72 to this side right here. I'm going to get 76. Okay, now I'm hoping that I can factor that. So I'm looking for factors of 76. okay, that are going to add to 40. Factors of 76 that add to 40. Okay, I got to come up here. So factors of 76. Okay, good. You can see all that. X. Well, it's okay. Well, actually, that's relatively clear. It's going to be x minus 2, x minus 38. Now, if you don't see that right away, you could use the quadratic formula. That'd be totally fine. So here, x is either equal to 2 or it's going to equal to 38. Now, just like in our previous questions, I don't know whether those both work, whether one of them works, whether neither of them works. I haven't got a clue. So I got to check my answers here. Now, in previous questions, like I said before here, what we would do here is we would look at restrictions based on the radicands here. But because I've got two of them, and because remember that part of the restriction comes from what is equal to on the other side. So like you can't take the square root of a negative, but the square root will also never be negative. It just gets that much more complicated when you've got two of them there. So the easiest thing that you can do here right now, the most straightforward thing you do, is just plug in the two numbers. Let's plug in 2. So 2 times 2 is 4, plus 5 is 9. The square root of 9 is 3. Okay, so this thing here becomes 3. 2 minus 2 is 0. The square root of 0 is 0. 3 minus 0 is 3. So, hey, 2 works. Perfect. Now let's try 38. 2 times 38 was going to be, what do we got, 76? 76 plus 5 is 81. Okay, the square root of 81 is going to be 9. Now, what do we have there? 38. Yeah, 38 minus 2 is 36. The square root of 36 is 6. 9 minus 6 is 3. They both work. So both of those answers satisfy the equation. We got 2 answers from this one. All right, let's take a look at another one here. Same sort of thing as the previous question here. So when the square root of one more than a number. Okay, so the square root of one more than a number. Well, that's easy. One more than a number is simply going to be x plus 1. Okay? Is subtracted from. Okay, so that means I'm taking this away from something else. So the negative is going to come in front of that. And what I'm hearing here is, reading here is the square root of 6 less than. Okay, now we've already come across that. Less than means I'm subtracting 6 from something. Less than double the number. So the square root of 6 less than double the number. And the result is 2. And again, we've talked about that. The result is 2. That's my equal to 2. So there we go. Okay? Now, once again, I've got 2 radicals here. And just like in the previous question, I'm going to model for you what I suspect most of you should be doing with this. I think most of you should be isolating one of these radicals. And I honestly think bringing the one over that's negative makes the most sense because then everything's positive there. Does it make really that big of a difference? Not really. You could do whatever one you want, just as long as you're careful with the signs. But if I move everything over so that most of the signs are positive, okay, well then I'm kind of putting myself in a position where I'm less likely to make a mistake. I'm going to square both sides on the left-hand side because it's just a monomial. When I square that, all it's going to do is get rid of the radical. On the right-hand side, it's a binomial. I've got the 2 and the radical there, so when I multiply this out, I got to remember that I'm going to be distributing, so I'm going to get those 3 terms there. 2 times 2 will be 4. And then I'm going to get 2 times the square root of x plus 1, 2 times the square root of x plus 1, so there's 2 of those, which means that 4 multiplied by the square root of x plus 1. And then the square root of x plus 1 squared. The radical will just cancel and go away. There we go. So we got rid of one of the radicals. Still got that one there. So that's my next goal, is to get rid of that one. So I'm going to bring that x over. Get x. 4 and 1 is going to give me 5. I'm going to subtract that 5 from the other side here. This is already negative 6, so that's going to be negative 11 when I put that together. And then I get 4 times the square root of x plus 1. Okay, now I would love to get rid of that coefficient and bring it over. However, that's going to leave me with a fraction on the left-hand side because I don't have a multiple of 4 here, a factor of 4. That would cancel with it. So I'm just going to leave it. I'm not going to bother bringing it over because it's just going to create a fraction and I really don't want to deal with that. So I'm going to square both sides now. On the right-hand side, just like we said before, just remember that you square both of the factors here. So this will be 16, and that's going to get multiplied by x plus 1. The the radical will just disappear in this case. On the left-hand side, again, I just got to remember that this is a binomial, and when I square that, I'm going to get the three terms. So x multiplied by x is x squared. And then I'm going to get x multiplied by negative 11 twice. So it's going to be negative 22x plus, and then 11 squared is going to be 121. Now, over on the right-hand side, I'm going to multiply that 16 through. So I'm going to get 16x plus 16. Okay? And now I'm going to start to bring everything over, because it's a quadratic, and I want it equal to 0 here. So x squared, and what are we going to get here? We are going to get, what is that? Negative 38 when I bring that 16 over. And then 121 minus 16 will be, x plus 105. Okay, I'm just going to double check everything here. So I'm now looking for factors of 105 that sum to 38 here. Now, I'm just working on my calculator over here, so I'm not entirely sure what this is going to work out to be. I suspect this is my answer here. Yeah. Okay. Now, if you don't know off the top of your head, please, by all means, use your quadratic formula. However, 105 only has a small handful of factors there. And so it turns out my answer here is going to be negative 3, negative 35, which means my two possible answers are 3 and 35. Now, I'm going to go back up to the beginning here, and I'm going to check my answers here. Let's say it's 3. So 2 times 3 is 6, minus 6 is 0. Square root is going to be 0, which means that term kind of disappears. Now, I already know that this is a dead end. 3 doesn't work because of the negative in front here. Now watch, I'll verify this for you. If you plug 3 into this, 3 plus 1 is 4. The square root of 4 is 2. But the left-hand side here is negative 2. On the right-hand side, it's positive 2. So 3, x equals 3, is extraneous. Whoops, sorry. 3 is extraneous. It's not a root here. Now, let's check 35. Okay, 2 times 35 is 70. Minus 6 is 64. The square root of 64 is 8. Okay, so bear that in mind. This first term here becomes 8. 35 plus 1 is 36. The square root of 36 is 6. 8 minus 6 is 2. That works. So 35 is the answer that we're looking for. We only get one answer in this particular case here. Okay, so I hope after going through this you get a sense of how you should be solving radical equations. If you've got a single radical in the equation, just isolate it, square both sides. Please remember to square a binomial properly. Okay, there's a mistake that's going to pop up frequently. If you've got more than one radical, your best bet is to isolate one of the radicals first, although it's not absolutely necessary. Again, though, remember that if you've got a binomial, okay, to multiply that out correctly. If, like we had in this case here, you've got a coefficient in front of the radical, remember to square that in the process of solving your equation. The only other things that you need to be concerned about are the restrictions on the variable that you get from within the radical. Now in this course, it's really just the ones from within the radical. You don't really have to worry about what it's equal to, although that can certainly help. So anyway, I hope that puts you or sets you off in the right direction here.